However, if the result on substituting 0.00 and the left hand side is not true, then you shade off the other direction. That is to say, shade off above the line. Let's take an example of this again. For example, you have 2x minus y is greater than or equal to 5. We now write this as 2x minus y equal to 5. You have to make your y the subject of the equation. So, where is our y? We have minus y is equal to 5 minus 2s. So that your y is equal to minus 5 plus 2s. You can therefore write this as y equal to 2s minus 5. We will need just few points. You can sketch a table of value to be very sure of what you are doing. You have your s, you have your y. You can take a value when s is minus 2, when s is 0, and maybe when s is 1. So here, when s is minus 2 minus, let's even take s minus 1. Minus 1 times 2 will give us minus 2. When it is 0, minus 5. When it is 1, s is 1, 2 minus 5 is minus 3. Now, with these values, we will now draw our graph. Let's draw our graph. This is your s, this is your y, this is your region. Let's assume that this is your minus 5. And then, of course, we have here other values. So let's say we have these values here. We also have here minus 1. We have 0. We have 1. So what next? We have here that when s is minus 1, the value here is minus 2. So our y will be somewhere here, minus 2 here. So we mark this. Making y the subject of the equation, so we have y less than 2s minus 5. We can then draw your graph. This is our s value, y value, this is your region. When s is 0, y is minus 5. So I come over here, I put my minus 5. When s is 0. Then when y is 0, we now have 2s minus 5 equal to 0. So that our s is equal to 5 all over 2, which is equal to 2.5. But I would prefer to choose a value that will give me a whole number. So let me take when s is equal to 2. When s is 2, what do we have? Or let's take when s is 3. that will be 2 times 3 is 6 minus 5, which is 1. So when s is 3, we can mark a place here and we say this is s equal to 3, and then the value of y is equal to 1, and our 1 will be somewhere here, so we mark the point, it is 1. So after doing that, you can now draw a straight line through this point. As soon as you have gotten that, you can write your equation here. This is y equal to 2s minus 5. Not less than or equal to. It is the line that you are writing the equation to represent. Thereafter, alright, y is less than or equal to 2s minus 5. Now, let's make a table of value for this. Let's choose some values. We have s, we have y. Then let's make space for 3. When s is 0, when s is 1, when s is 3, when s is 0, y is minus 5, when s is 1, y is minus 3, when s is 3, y is 1. Then we're going to draw the graph representing this information. This is the origin. So when s is 0, let's put our y here is minus 5. Then when s is 3, assume it is here. I don't need to consider this because all will fall in line. The value of y is 1. So let's say this is where your 1 is. So you take a ruler and you join these points together. You can therefore write here the equation of this line, which is actually 2s minus y equal to 5. That's the equation of this line. Now we want to consider something, and that thing is the point 0, 0, so as to know which area to shade. So if you look at it very carefully, you have your 2s minus y is greater than or equal to 5. So our test, substitute the point 0, 0. When s is 0 minus 0, this will give us 0, greater than or equal to 5. Is this true? No. False. Then don't shade towards the origin, shade the other part. Don't shade toward the origin, but will not shade to other part. That is what the test is telling you. If it were true, we will shade towards the origin, 0, 0. But since it is false, you will shade downwards. So shade downwards, like this, like this. This is not the region where the solution lies, and you will have solved the problem.